Hey, 7th graders, I'm just kicking it here in my awesome Grinch outfit. Obviously, I filmed this before Christmas, and I'm roasting. I can understand how the Grinch was so crappy. Anyway, I'm going to explain to you guys today your assignment, which, as you can see, is found in Teams Assignments. So, as I've been kind of trying to reiterate with you guys, is we're not doing as many in Amplify as well. They're still based off of Amplify, but we're going to try to kind of do them in these PowerPoints. So hopefully you found it okay and you found the video okay. Today's blend will be a little bit of Amplify 3.1, 3.2, and 3.3. So again, we won't be doing anything in Amplify. We're going to try focusing on things in just Teams Assignments and see how it goes. So your learning targets for today is I can predict and test the genotypes and phenotypes of offspring. So if we were to make a match between, in this case, the spiders, in the sim, can you predict, based on what the parents are, what the offspring might look like and what their genotypes might be? And you can also model how sexual reproduction passes down in genes, so you guys can kind of see where sexual reproduction obviously contributes to how genes are passed down and why, like, for instance, you are so different than maybe one of your siblings. Okay? So those are our learning targets we're going to focus on today. To kind of get you guys started today, you should have added 2 things into your OneNote. So your 2 vocab words for today are sexual reproduction, the process in which 2 parents pass their genes to create offspring, and inherit, to receive genes from a parent. So obviously you inherit things from them, like your eye color. Then you have 3 key concepts to add. So we have key concept number 10, organisms inherit their genes through sexual reproduction, which is basically the vocab you just had. Key concept number 11, each parent randomly passes on one of its 2 copies of each gene to an offspring. Each offspring, therefore, receives 2 copies of a gene, 1 from each parent. So I have 2 copies of my eye color gene, okay? If I were to have kids, I could pass down either this copy or this copy, okay? So maybe they're both the same. Maybe I have 2 genes that give me brown eyes, but maybe I have a brown eye and a blue eye one. Brown is dominant over blue. I could either pass down the brown or I could pass down the blue. So we'll get into that a little bit more too when we talk about Punnett squares. And then key concept number 12, through sexual reproduction, each offspring can inherit a different combination of gene versions. Therefore, siblings can have different traits from each other and even their parents. So just because my parent passed me down, or both my parents technically probably passed me down a trait for brown eyes, doesn't mean that that's the same trait that's passed down to my brothers, because it's all pretty random. Okay? If you guys obviously are watching this video, you found the link, but here's also the link for you guys. Moving on to activity 1. So, awesome thing, you guys can click right here, open your link, and it should take you guys right into the Amplify Sim, assuming you are signed in through Clever, which I have not done yet today. So I'm going to go ahead and sign in on that. And while we're waiting for that to open, I'm going to go ahead and look at the directions. So for this first part, you guys are going to mate a female and male spider. I'll show you guys kind of the process of doing that. You'll click on Create Reproductive Cells, which are sperm and eggs. And then once the cells have been produced, then press Randomly Fertilize. So we're going to create a bunch of sperm and a bunch of eggs, and then we're going to hit Randomly Fertilize. So you guys won't get to necessarily pick which ones, which sperm and which egg we're going to use. And then we're going to observe what happens upon fertilization. And then we're going to compare the offspring with each other and with their parents. So you guys will kind of look at how much do they look like their parents, how much do they look like each other, and then what their gene versions look like, their genotypes look like. So pick one feature to observe closely, don't do body size, and answer the questions below. Okay, so here's what our questions look like. So let's go ahead and choose anything but body color. So maybe you guys choose Venom. You guys, obviously, this is an example for you guys. Choose a different thing if you guys want. Maybe I'll do Bristle just for fun. So obviously I need to find a male and a female. I'm just going to grab my first 2 spiders. You guys will click one. It doesn't matter which one you guys click. Click it and drag it until the circles line up. Okay, so now we can see, all right, here's Greg. This is his trait for Bristle. He has none. Versus Zora has dense. Here's her genotype R1R1. Here's Greg's genotype R2R2. So let's go ahead and create reproductive cells. Okay, so here is the different combinations that Zora could pass down. So these are her eggs. So she could either pass down this gene, this gene, this gene, this gene, this gene. If she's R1, really the only option she has to pass down is R1. Versus Greg here has the genotype R2, so he could either pass down an R2 or an R2. Okay, so you can see all of Greg's sperm down here all have the genotype R2. And then we're going to click randomly fertilize. At this point, you guys can kind of make a prediction of what the children might look like or what their genotypes might be. Because if Greg can only pass down R2 and Zora can only pass down R1, those are going to combine in the babies. Okay, sperm and egg combine or fertilize. And we should see R1, R2 for their genotypes. So let's test it out. Okay, so we have offspring number 1, R1, R2, like I said. R1, R2, R1, R2, R1, R2. They wrote theirs a little backwards. But you guys can also see that all of those have sparse leg bristles. Okay? So in your questions, you would say, all right, I mated this female spider. I think in the case of ours, we did Zora and Greg. So you guys will go to your draw feature. Pick a color that I will be able to see. I'm going to use black. So here's Zora, and then I mated her with Greg. I chose, let's see here, bristle for mine. You guys obviously will do however you chose. I'm assuming you guys chose something different. Okay, and then you'll need to click back on your cursor to answer these 2 questions. So click in your text box. How did the offspring traits compare to their parents' traits? So if you look back and say, all right, Greg had none, Zora had dense, but all the offspring were sparse. You guys would want to write that. Okay, one parent was dense, one had none. All of our offspring were in between that and had sparse. Okay, how did the offspring's alleles compare? Oh, excuse me, that was the question for this one right here. This one said, how do the offspring compare to their parents' traits? So yeah, that was the same, sorry. So you guys would say it was different, right? Neither of the parents had sparse, they were different than both of the parents. Okay, how did the offspring's alleles or gene versions compare to their parents? Well, you guys can see in that if we're looking at their genotypes, they were all R1, R2 versus this parent had R2 and this person had R1, R1. So you guys might say, well, they had one of each, right? So they had an R1 from Zora and an R2 from Greg. So you guys would just kind of describe based on whatever you guys saw, because obviously you guys wanted the exact same thing, how those offspring, their phenotypes and their genotypes compared. Okay, moving on to activity 2, you guys will be in the same simulation. Here's the link again if by some reason you closed out of it. Otherwise, you guys can just refresh and reset. Okay, press body color to observe Otis and Ann. So we're going to look at body color, and we're going to be looking at Otis and Ann. So we're going to go ahead and just mate those 2. We're going to press create reproductive cells, so that'll produce what egg and sperm that those 2 spiders could pass down. And then again, we're going to randomly fertilize them, because that's how nature works. We usually don't get to pick, okay? We can't really see what genes look like per se, and it's harder and harder for us to pick. And then examine the traits and combinations of the genes for each offspring. So if we go to the next slide where we have questions to answer, notice the big old question mark, okay? We are going to first talk about Otis and Ann's genotypes and phenotypes. So you guys should be able to click in these boxes and type. My computer's frozen up a little bit right now. Okay, but let's just take a look. All right, if we look at Otis, we're looking at body color. Otis has the phenotype of a brown body color. His genotype is C1C3. Ann, on the other hand, is colorless. Hers is C3C3. So you guys would go in here, you would click, and you would say, all right, here's my cursor. That's why I couldn't click. Make sure if you guys can't click that you guys go back and change it to your cursor. That was what I did wrong. Okay, so Otis here has the genotype of brown. He has C1C3 as his genotype, or phenotype is right there. Excuse me, brown. And then C1C3 is his genotype. Okay, so you guys would type that information in there. I'm basically doing this for you guys, okay? You guys will be doing this first part in class, doing the exact same example, so you don't get to choose anything different on this. Then if we look, Ann is C3C3, and she's colorless. So her phenotype, her physical appearance, as we can see, she's colorless, and she is C3C3. So you guys would type that in just like I did there. And then we're going to go ahead and create reproductive cells. So we can see that Otis has two options of alleles he could pass down. He could either pass down the C1 or the C3. So you'll notice that about, not quite, but close to half of his cells are C3 and then the other are C1. So you can see how he passed down both. Versus Anne, she has all C3 because all she could pass down is either a C3 or a C3. Okay, if we go randomly fertilize, let's see what their offspring look like. Okay, so if they had 4 babies, or 4 little baby spiders, we would see a colorless, same genotype as mom, brown, same genotype as dad, colorless, same genotype as mom, and again, same colorless there. And then again, another colorless with the same genotype. So 3 colorless, 1 brown. Okay, so you guys would go and say, all right, offspring 1 got which allele from Otis? So let's take a look. Offspring 1 could have either gotten, so here's offspring 1, spider 1. Okay, we noticed that it got a C3 from mom. So all of these C3s that the offspring get all came from mom because that's all mom could pass down. So if we look at this first spider here, it has the genotype C3C3. It got one of its C3s from mom. Where did it get its other C3 from? From dad. Notice that the dad still has a C3 there. So in this one we would say, all right, from dad he got a C3. From mom he got a C3. The offspring's genotype was then therefore C3, one from mom, one from dad. And the phenotype was colorless. Okay, I'm going to do part of this table for you guys and then I'll let you kind of finish the rest. Your guys's might look different because when you randomly fertilize, your guys might come out with a different ratio, okay? My next one though, I see obviously again, mom can only pass down C3. So if we're looking at this second spider, it got that C3 from mom. So what did it get from dad then? Must have gotten the C1 from dad. So from Otis, C1. From Anne, C3. And then what's that spider's offspring? C1, C3, and it is brown. Okay? So go ahead, fill out your guys' last 2. You guys might have 2 spiders that look like this. You guys could keep that if you want as your examples. Otherwise, do your own example and fill out the rest of this table on your own with what you guys were able to see randomly in that mating. Okay? Moving on to activity 3. You guys, I'll do this first one for you guys. So we're going to look at Greg and Anne, and we're going to talk about silk stickiness. I'm going to show you guys how to make predictions, and then you guys will do the same thing. You guys will take Otis and Ruby. You will make predictions for body color, just like we did together on the last side, and then you guys will test those predictions. But let's just not get too far ahead of ourselves. Let's go back and do Anne and Greg. So I'm going to reset my spiders. I'm going to choose Greg and I'm going to choose Anne. And for this one, like I said, we're doing silk stickiness. So here's my trait for silk stickiness. Here's Greg and here's Anne. Okay, so let's just take a look at what we need for our silk stickiness. So first, let's talk about Greg. Greg's gene versions or his genotype for silk stickiness are... So if we look at Greg, he is S1, S2. So we would type right here, S1, S2. Okay, I'm going to leave this filled in for you guys so you can kind of use it as an example. Everything else will be deleted though. Greg's trait for silk stickiness, so that's his phenotype, would be sticky. So he's got that sticky spider silk. Okay, Anne, on the other hand, has a different genotype. So Anne has S1. Oh, she has the same. Look at that. They have the same stickiness. I was going to think they had different ones for some reason. All right. So she's sticky S1, S2 as well. So also S1, S2. And she's going to be sticky. Okay. So then down here, I'm going to make predictions. So if Greg could pass down either an S1 or an S2, Mom could pass down either an S1 or S2. We're going to go ahead and make some predictions. So see how many different combinations of those you can make. So allele from Greg. Maybe Greg passes down an S1, S2. Is this not letting me type? There we go. Fix this really quick. All right, here we go. So Greg can either pass down an S1, or he could pass down an S2, and on the other hand, could pass down the same thing, either an S1 or an S2, but are those the only combinations of genes they could pass down? So could Greg pass down another S1, but Anne, instead of passing down an S1 as well, could pass down an S2, okay? Or Greg could pass down an S2, and instead of Anne passing down an S2 as well, she could pass down an S1. Okay, so we've basically taken and combined and seen how many different combinations of these we can do. When we're talking about Punnett squares, this will make a little bit more sense to you guys. Okay, so that means that the offspring would have this genotype, S1, S1, or it could have S2, S2, or S1, S2, or another S1, there we go, S1, S2. Okay, so we could see that maybe the offspring are S1, S1. Looks like a 1 out of 4 probability. Or 1 out of 4 could be S2, S2. Or 2 out of 4 could be S1, S2. So then you guys would actually go and make that prediction and say, all right, let's create our reproductive cells. And then let's randomly fertilize those reproductive cells to see what combination we actually see with this. We should see more S2, S1s, or S1s, S2s, excuse me. So here's S1, S1, S2, S2, and then look, we've got 2 S1s, S2s, just like predicted. So these are sticky, sticky, and then not sticky. So then basically you guys are going to do the exact same thing. You guys are going to use Otis and Ruby. You're going to look at body color, tell me what the genotype and phenotype for Otis is, and then the genotype and phenotype for Ruby. And then you guys will do the exact same thing we just did. Make predictions, okay? Figure out what different combinations you guys can do between what Ruby can pass down and what Otis can pass down, and then combine those to form the genotypes of the offspring. Then go in and test. Okay, you're going to want to test it twice. So you guys would actually go make Otis and Ruby. You would test it once and you would tell me, all right, what are the offspring's genotypes and what are their phenotypes? Reset it, do it again, and then tell me what are their offspring's genotypes and the offspring's phenotypes, and then answer this question right here. All right, to wrap up your guys' assignment, you guys will use your draw tool. Do you have any questions? Circle yes or no. If you have questions, type them in right here. Obviously, if you have something that will prevent you from doing this activity, you guys can go ahead and ask me right away in Teams so I can help you finish the activity, and then rate yourself. How well do you think you did on this? And then go ahead, turn it in. I hope you all are having a wonderful day, and I will talk to you soon. Bye.